Okay, I just wanted to check what is the problem.
No, actually, Nilesh, please share. Rashmi and Nilesh, please share exactly what is your observation. Either Nilesh or Rashmi. Both are not here.
I think they were there just now. Maybe they went out.
Okay.
We'll just wait for them. So it's not a problem. Yeah, the meeting is still going on for the Kerala state.
Okay, sir. Sir, you can share your presentation.
Okay, I will.
So we want to complete it by 8 o'clock, sir.
Okay, sure.
8:15. Exactly. You have 1 hour and 15 minutes.
Yeah. I don't have that many slides also, but we can finish it off exactly at that time. Then.
Okay, sir.
No problem. So we will be done. So when the students come in, they can interrupt me to tell what is the problem. But let me just, since I'm sharing the screen, I will show what is the issue, or there may not be any issue, but I'm just, okay. So when you unzip the package, you will see that it will create a directory called flood sim PUC package. And then you can go to 3D if you are using 3D glasses. You can go, and then this is the application. As soon as you see application, you can click on that. When you click on that, it will ask you, depending upon the resolution of your screen, if you have a high resolution or a low resolution, you have to select so that it works appropriate with your resolution. So once you say play, it automatically starts the whole process. Now that is for the 3D. I usually use 3D, so if you see any issues with the regular package, let me know. Then I can check if there's any problem. I can always get back to you and explain that. So that's one thing. Professor Yadav, I also wanted to check with you. Is there a survey you will be conducting for the participants about the course? Hello? Can you hear me?
Sir, the participants will be submitting the feedback on GYAN website only.
Okay, I just wanted to check. Okay,
yes,
so is this Rashmi?
Yes, sir.
Okay. Rashmi, so, we have called you for that software. What difficulty you are facing? That I just wanted to know.
Sir, actually, we wanted to know how to use this software for our area. Means how to give the inputs of our area, which the model we have developed and the flood inundation maps we have got. So
unfortunately, no, we cannot do that. Unfortunately, because this is a case study specific. Because the whole rendering of the neighborhood and everything is done for that region. So. You can develop something quite easily, but it will take some time to develop the rendering of the objects for your area. So that is the problem. But this particular what you call application is only for the location of interest. But if you need more details, how to develop this package and how to use it for your area once you have the HEC-RAS models, I can get you all the details for you. Okay?
Sure, sir. Thank you, sir.
Yeah, you're welcome. So, but otherwise, see if you are able to simulate the conditions, you're able to move to different streets, and then if you have a 3D glasses, see how the effect will be if you have a 3D glasses. It doesn't have to be very expensive glasses. You can just buy some paper ones, which they give it in movies or anywhere they are available. 3D glasses are very simple to find, so you can use that to check the 3D virtual reality mode. Okay, so so the last and final topic aptly is that we have gone through all the issues related to flood estimation, flood modeling, spatial analysis, spatial data generation. Then we talked about forecasting models. Then we also talked about the inundation map, spatial representation, and everything. So we have basically done all the background work for us to understand the flood estimation as well as forecasting. Now, of course, flood warning is a completely different animal, because we are now dealing with people who are involved in trying to communicate the results from the modelers. So either we have either operational forecasting models in case of ensemble stream flow forecasting models, or any simple rainfall based runoff models like HEC-HMS plus HEC-RAS combinations, or distributed hydrologic models. So anytime you are talking about the results from these models, depending upon the lead time, the warning agencies, the agencies which are responsible for warning, have to provide the warnings. So one thing we need to kind of distinguish, we know that already, but we need to distinguish between flood forecast and warning. Flood forecast is something what we call the scientific evaluation of an event in real time. So with quantitative estimation of magnitude and timing of flood using simulation models. So in a sense, when you say forecast, we are providing some idea about what might be the quantity of the magnitude of flood expected, the peak discharge expected, and that information is given to the public also. Sometimes we can, like in the case of United States Geological Survey, they provide that information. But at the same time, the Federal Emergency Management Agency, we have FEMA, that is the agency which is responsible for giving all the warnings. They will go ahead and use that information, and they might also have recommendations for the orders for action, such as evacuation, emergency flood proofing, which is designed for safeguarding life or property. So in the sense, so flood warning is something which is intimately linked with flood forecasting, but at the same time, it is a separate entity which takes into effect the region-specific issues and the other things. Okay, so now, can we use this as a research activity? Yes, but as long as you are looking into some new innovative methods of developing flood forecast warnings. For example, one idea comes to my mind is that we were seeing Professor Yadav's work with the student using AHP to come up with some kind of a ranking of the flood risk zones as well as the impact zones. So maybe we can use the AHP and then multi-model ensemble forecasts to come up with some consensus to say what should be the warning. Should it be a danger levels, different levels, and so on. So that can be a nice area of research where you are aggregating the responses from different modelers forecast. So, but otherwise, we still need to know what is the association of warning systems and how warning systems can fail sometimes, and so on. So in case of flood warning, we have detection, thresholds, and dissemination. The detection is obviously we look at the meteorological components, tidal conditions, and then of course we also look at the weather prediction if you are interested in the short-term quantitative precipitation estimates, or looking for something what will happen tomorrow or day after tomorrow with high accuracy. So you'll go for the numerical weather prediction models. Now for the thresholds are much easier. They can be constructed with either manual based process or automated process. Automated process in the sense that you have sensors at different locations and they register the values of rain or flows, and they automatically communicate to the office where the other works get done, and they based on the specific threshold they have established for different seasons, they can initiate the warnings. And then, of course, once the warnings are initiated, you have the dissemination process where you issue the warnings to local authorities and so on. Flood forecasting, again, we know that models for forecasting future and river as well as coastal conditions. Coastal conditions are also important in many cases because we have this nuisance floods and storm surge floods which come in from hurricanes and so on, or cyclones, and that water comes into the land, and that is what. Recovery, response, and review and preparedness, all these things are the next steps, and this is how we respond to the flood. Again, you have a number of things which we as researchers may not be responsible, but if you are to be working in an agency which is responsible for all these activities, then you have to focus on emergency works, how to debris removal and shelter, water, and other emergency preparedness measures. How do you prepare for an impending flood? So, what are the benefits of warning technology? First of all, flood warning technologies provide advanced warning of flood events, which can potentially allow the risk to be minimized. Evacuation of vulnerable groups like old people, physically challenged people, and then children and low-income groups in some areas within the region, and so on. Residents to move assets to safer locations, food, livestock, and personal effects. Timely operation of flood control structures. So this also really helps how to use storm surge barriers, temporary flood defenses like sandbagging and all those things, inundation of property land, and installation of measures and preventive actions to ensure that there is no obstructions in your channels and so on. So within the warning systems, there are two. One is the watch and the warning. Watch is basically instruction that flooding may be possible, and they're asked to listen to the radio or TV news later on, so that they'll be basically they've been alerted that there'll be something happening and it's expected. But the warning is something which is imminent, that the flooding is imminent, and then you have to evacuate or move to a higher ground. So depending upon the drought or a flood threshold, you can decide the thresholds at which you give the warning or the watch. In this case, watch is at smaller level, so you're basically telling people that there can be a flood. And then threshold, which is warning, is at a higher level. Okay, so that's. But then there's also an advisory, which in United States we offer that. And this is basically telling them what might be the situation. Then there can be a number of hazardous situations where they have to be careful and where they can move to different areas if there's any problems or anything. So this is more of an advisory that something is going to happen. So warnings based on thresholds. Basically what we do is we can use river level forecasts and then issue flood warning if the observed value is exceeded or if the forecasted value is exceeded. So there are two things. One is you are actually making observations. You're also trying to forecast a water level or a stage at a particular location of your stream or river, and then you can use that information to provide a warning. And then at the same time, you can also consider issuing the warning if the observed level is exceeded using forecasted outputs to take the final decision, and also warnings to individual properties or group of properties from real-time forecast of the inundation extent. So that means if you know the inundation extent, then based on the forecast, you can provide warnings also. So the importance of flood forecasting, we know that we've been forecasting it. Of course, it depends on the type of catchment or a basin, physical processes affecting the initiation of the flood, forecast lead time, okay, that is important for us. And then the data requirements are hydrological data, meteorological data, we already seen that, and these are all very important for flood forecasting. So 6 components for flood warning system. Monitoring and prediction, interpretation, of course, message construction, how do you develop the message? You should not alarm people when there is not much situation going on, but at the same time you need to be careful. And then communication, protective response, and then review. Once you have done it, once you have made the whole process of flood forecast and the flood has passed, then you review and see whether your flood warning system has worked in a way you expect. So the challenges are development of national and regional systems, large-scale continental modeling and monitoring systems. There are a lot of agencies, international agencies, are working at a global scale to provide some idea about forecasts, especially those basins where there are no gauges and no responsible agencies are doing work. So you take satellite-based or any type of inputs you can get, and then use them in simple models or threshold models to come up with some kind of a large-scale basin forecast, especially those ungauged basins. And then real-time, near real-time forecast systems, applications, and post-mortem assessment once they are done, and then see. And forecast dissemination is another problem. So how fast we are able to spread the message, and then how much is the reach, what extent the message is reaching. So recently, Pagano has created a nice survey of many of the countries having a good forecasting, flood forecasting systems. And you can see that India doesn't be listed there. And in some places, I have seen Bangladesh being listed as one of the countries which have advanced in trying to develop more forecasting systems. So again, each country is using different types of inputs, like radar or satellite. Some of them are using lumped or semi-distributed methods. And then do they have a real-time inundation mapping capability or not? Are they doing simulation of reservoirs and so on? So this is a very nice comprehensive survey, including coastal forecasting, precipitation forecast, and the lead time, and then the maximum lead time, the forecast frequency, how often the forecast is made, and the other things is what type of models they are using for different aspects of the forecasting. And also the whether they are categorical or deterministic, probabilistic, ensemble. Some of them are doing ensemble, some of them are not doing. As you can see, Australia is not doing ensemble. UK is doing ensemble. Brazil is doing ensemble. United States is doing ensemble. Okay, so understanding the processes and variables is very important. So a flood forecasting or warning requires an understanding of hydromorphological characteristics, topography, geology, of course. And then depending upon the type of basins we are looking at, this is a table from WMO, they indicate that depending upon the size of the basin, the nature of the basin, whether it is controlled by groundwater systems or it's estuaries or medium-sized rivers or upper watersheds or small to medium catchments, the response time will be different. So that is important for us. And then also looking at the characteristics of the basins, if it's densely populated and so on. So therefore, the forecasting as well as warning system depends on a number of factors which they are listing here. So the services to be offered by the warning systems are typically like this: threshold-based flood alert, flood forecast, vigilance mapping. That's basically the site-specific mapping and map-based visualizations. For example, color coding, you can say green, yellow, and so on. And of course, inundation forecast with digital representation of the floodplain. Some warning systems use triggers. So these triggers are, important for the agencies to provoke some actions or to have information from external users. So what they do is, for example, if you have rainfall, the accumulations exceeding a specific threshold in a specific time period can be used as a trigger, or rainfall accumulation catchment wetness conditions can also be used as a trigger. And in this case, sometimes you might expect flash floods. And then in case of other triggers, the level at which, for example, if you're looking at the channels, the level at which water flows out of the channel into the floodplain, that can be a trigger. The level at which water submerges areas, land used by livestock and low-lying roads become flooded. It's basically less densely populated, but where you are getting a warning signal that it is flooding, so that means it's a trigger. major areas, then you can look at it. And then the level where the depth and velocity combined pose a threat to a structural damage or a danger or loss of life. So these can be some triggers which can be used. So the forecast lead time, we asked this question, minimum period of advance warning. So impact for residents to evacuate. So when you are providing a warning, in this case, we can call it as a warning lead time. So you are also thinking about whether are we providing enough time for the residents to evacuate, and especially the large time for high impact areas from days to from a day to days. So that indicates that you can go from 1 day to 3-4 days or something like that. Somewhat like time of concentration, in the sense that how much time a person who is staying in a community can get out of the community. So that's the maximum time. So they should take into consideration when they are providing the lead time for forecasting. Lead time consideration for warnings, we just talked about that. Size of the catchment, nature of flooding. If there are large basins with flat terrain, it will be slow response. We don't have to worry. Basins with steep, hilly terrain in headwaters, for example, what Professor Yadav discussed, a tremendous amount of rainfall on Mount Abu, that requires consideration for lead time because it's a fast response. We need to consider risk and impact considerations, evacuation consideration, and also time for protection. So if you think that some regions can be protected, you need to start thinking about probably giving more time to the emergency management professionals so that they can go and protect using sandbags and other type of things. And of course, other factors which contribute to you to decide the lead time when you're making the forecast. The data and personal requirements, we already know that we need comprehensive data, we need infrastructure data, we need social data, we also need resources, for everyone to collaborate to develop warnings, both expertise in hydrometeorology and meteorology, IT personnel, communication specialists, how to craft the message and how to deliver the message to people, and also the research and development professional to evaluate the efficacy of forecast warnings and model performance. This is very important after the forecast is given, and when people heed to that and then leave or whatever, how effective was the forecast, plus the warning. So the forecast model development is something, this is more of a generalization, define the purpose, modeling the context, conceptualize, select model features, choose performance criteria, and validation, quantifying uncertainty, and so on. So this is our typical forecast model efficiency, how we check. So watches and warnings are provided by forecast agencies in United States. There's a difference between watch and a warning. Okay, these are updated at regular intervals, and this will help us to understand the state of the system when forecasting models are rerun, considering the state of the system with available sensors and instruments. Some of the examples of flood warning systems, this is from UK, flood watch, flood warning, severe flood warning, and all clear. These are available on their website, their forecasting website or warning website. And they also provide flood alert, flood warning, severe floods in the form of those symbols that will really convey the message graphically. So then if you look at cyclones and hurricanes, we have the National Hurricane Center, which is the lead agency in the US tasked to provide hurricane forecasts to the public. They also provide watches and warnings of tropical storms, depressions, and hurricanes. And they range anywhere from 15 days to several hours. So that means they do a very good job of providing those warnings. So here's an example of how they provide the forecast. So this is the most recent plot. This was taken on June 15th, and you can see that there is a small area of disturbance which is crossed plus sign, and then there's a hurricane symbol, that is the one which is brewing on this side of Mexico. It's not a big threat to the United States, but still it might come back to California, and it will affect. But then they provide this, what they call the cone of uncertainty. So what they do is they basically use a number of models to come up with the circle of influence at different time intervals. So they'll have all these circles placed on each other, and then they combine those circles to form this cone of influence. So this is your cone of influence. As expected, when you are close to the point of forecast, you are very sure where the hurricane or the cyclone is heading. And then, but as you go away from the point of forecast to the lead time or whatever into future, for example, this is Wednesday, this is Monday next week. So they say that this hurricane or cyclone is slowly becoming a storm. Instead of becoming a hurricane or intensifying and going this way, it is going that side. So that's what we call it as a cone of uncertainty. But the central line is most probable path of the hurricane. But at the same time, this width gives that anywhere in that width is a possibility that hurricane can move and change its direction. So therefore, this cone of influence is something which is very important for us. So let's say, for example, this area is there and people are affected by that cone of influence. So they have to evacuate, or at least they have to start thinking about there's a possibility that we will be affected by the hurricane. They need to take precautions of that. And they say here, the cone contains the probable path of the storm center, but does not show the size of the storm. That's one thing. And hazardous conditions can occur outside of the storm also. So that's another warning they give. So this is for the 7 days. This is for 3 days, and so on. So you can see that it is slowly getting smaller and smaller. The flood warning systems, these are some of the flood warning systems, and you can see that there are websites, so you can actually go there and look at them. They have location maps, they have regional and catchment maps, they have station level plots and forecasts. So you can see that Bangladesh has a nice website providing the water level plots and forecasts, and also they have information from different catchments and station level plots and forecasts for United States also. So the forecast happens in 13 river forecast centers across United States. These are the forecast centers, and they are responsible for that area, whatever they are covered in that color. And then they give anywhere from weeks to months. They provide emergency alerts. They also provide alerts on the radio, and they can be county specific. That means like a state, not state, but small divisions within the state. And then it can be lead time from 12 to 48 hours or sometimes less. And then they provide information about large-scale flooding and also gradual riverine flooding that is happening. So just to show you, I think I have an example of that. So here's an example of the National Weather Service, and you can see that how they are providing the warnings. These are the sites at which they have locations, and and you can see that is the river forecast center responsible for our region, and this is the one-day forecast through 16/18. So for the next 1 day, they are expecting these are the things which will happen, and most of them there's no flooding excepting some minor flooding in some places. Then we can go into a little bit more lead time to see see what is happening in some places, and then we can go as we increase that time frame, or we can look at the entire time period from now to 23rd of June, and that will give us what is happening in that system. So these are our river forecast centers I was just showing you, and we can go there to get to that location to find out what is going on in our particular area. Of course, these are all site specific and gauge location specific. So these are real-time gauges based on which they are providing the forecast. So typically when you provide operational forecasting and warnings, this is how it works. This is from WMO again. So you can see there is an operational center. They can use meteorological forecasts, rainfall triggers. They can use radar. They can use telemetry, river gauges, and gauges on the river gauges. Local observers can also provide information. They have the damage infrastructure and higher stage triggers, first stage river triggers, and so on. So Operation Center receives all this information, And then when the river commences the rise, they see the flood status, then they can initiate the alert, severe flood warning, emergency mobilization, and then once the river height or stage declines, then they will downgrade the warnings. So this is the typical flow of information. So I wanted to just touch base with a case study where we had a huge cyclone called Katrina sometime in 2005, and this was a wake-up call for all emergency agencies. And this happened to hit a big city called New Orleans, which is on the south in Louisiana. And this has all important hydrological aspects as engineering aspects written over it. So I thought I would just discuss a little bit about this particular problem. Just to say that how hurricanes form, and then what is the main contribution factors, just quickly, and then what are the hydrological considerations, how Hurricane Katrina manifested, and what are the problems we have seen, and what was the problems associated with the warnings, and how there are thousands of people who lost lives, and also there were people who were, lost their homes, and they had to change their whole lives altogether because of this hurricane. So what was the main problem here? If you see, hurricane was a partly contribution, but the main problem was the city of New Orleans is kind of located below the sea level. Okay, that's one thing. And then it is located at the lowest point, and there's a Mississippi River which goes inside the city that is at a higher elevation than the city itself. So the city is below the river level, and it is below the sea level. Okay, so there should not be any city in the first place. And then there's a huge lake, it's called the Lake Pontchartrain, and if there's any break in the levee of the lake, that water will completely flood the city. And this is what happened, but of course contributions are from the hurricanes also. These are the hurricane formation areas we typically see around the world. You see that India also has 2 active sites of the area where you have hurricanes. We also have hurricanes here in Florida, and this side we just saw a hurricane brewing some time back in the Mexico region and so on. So typical requirements, as we know, water, warm air is lighter, it goes up, and then it accumulates over time, and there should be a right conditions, the sea surface temperature, and of course. And then it has a typical warm core, low pressure system. We call it as depression. And then it's a front attach that develops into a circulation. And then we call it as different names, hurricanes in our case, typhoons in Western Pacific, Japan, Korea, and so on. And Indian Ocean, we call them as cyclones. There are a number of minimum requirements for the temperature and so on for the hurricane formation. We don't want to learn all these things. But for us, the hurricanes come from the trade winds which converge. They slowly start from Northern Africa, and they create a zone of disturbance. And then slowly, because the conditions are moist, warm moisture is available, water is available, it's a very nice brewing conditions for hurricanes. And then slowly they form into the low pressure systems. And then because of the Coriolis effect, they start rotating. And then you will see that these are the categories we classify depending upon the speed of the winds we see. And typically there is an eye, and then there is a firewall, eye wall. And this one like this, and all the rain bands will produce the tremendous amount of rainfall. And it starts spinning, and it moves towards one area, and then it picks up more air and more water in that process. And these are the scales we use, for example, which is called the Saffir-Simpson hurricane scale: catastrophic, extreme, extensive, moderate, and minimum. This is based on the wind speed, the speed at which the hurricane is moving. And we also have tropical depression, tropical storm, which you are aware of. And then, of course, hurricanes, which are the most. So typically what happens during a hurricane, we also have a storm surge, which will come into the coastal areas, and then it will flood the coastal areas. Fortunately, we will not have a lot of houses which will be flooded, but if there are flooded, there will be a damage. And this is a situation when the coastal areas are a little higher. Even though you have a coastal surge, you will not be able to affect this thing. High wind will damage everything in the route of the hurricane when they make the landfall. So, and also the wind shear, that is very important to have above normal hurricane season. We always do the projections for the future. What will happen in the hurricane season this year? That means from June to November 1st, we have a hurricane season. So we project how many hurricanes will happen. For example, 2005, where this storm has happened, the number of storms are projected to be around 81. Major hurricanes 5 to 7. It was above normal activity year. And we also saw above normal sea surface temperatures in July of 2007, which was just ready to help the hurricane formation. And then these are the conditions that were expected at that time, and that was the forecast. And we have already seen how the forecast, see the tracks of hurricanes change with respect to month. And you can see more number of hurricanes happen in August and September that are close to Florida. And then they go away from Florida in October, and then finally move away from November. So this is the actual hurricane picture from space, the Katrina. And you can see the eye of the hurricane, and this was moving towards Florida. And we use typically a hurricane hunter aircrafts. They actually fly the aircraft into the eye of the hurricanes, and they look at the speed of the wind. They look at other measurements. They drop these sensors into the hurricane itself, and then they measure all the parameters. So these are the flight planes which go into the hurricane. So this is one picture of that Hurricane Katrina, where the planes are inside the rain bands, the whole hurricane, and they are going through that to find out what is the estimate of the wind velocity and everything. And these planes are very rugged. They will not be destroyed. They know how to fly it. You need to be a very experienced pilot to go through this. So these are the rain bands. You can see that how these rain bands happen. And this was Hurricane Katrina moving towards Florida and Gulf of Mexico. So this is moving towards what we call, this is the New Orleans area, that is the near Texas. And moving, and then it's on top of New Orleans. And that's the eye of hurricane. That's the actual picture. And as I said, it will cause a tremendous amount of damage, and there will be tornadoes, there will be floods. And this is what is the New Orleans area looks like. So you can see that this is a city, a lot of wetlands around, and this is the Mississippi River, which goes through it, joins the Gulf, and that is the Lake Pontchartrain, one of the big lakes. So this river is at higher elevation than the city itself, and I will show you. These are the surge heights, how much water got lifted up to 10 feet and 20 feet in some places. And this is the path of hurricane. So actually, the hurricane did not affect the city much. It went northeast of the city, but it caused the wind damage. And there are so many locations of what you call oil rigs where they pick up oil from this place. It's very rich in oil. And you can see the Mississippi River. So what happened during that wind, there were breaches at different places. The Lake Pontchartrain had a breach, and the water started going in, and this was the breach at one of the canal sites. Water started moving in because the winds were so high. They started, the wind effect had an effect on the water waves, and the water hit the concrete barriers and also the protective barriers of the canals, and they breached. And the multiple breaches happened inside the city. This is one, these are two. Again, this one. So based on that breaches, we started seeing water coming into the areas. And how the breach happened, this is basically the levee failure process. We have this kind of earthen dam and a concrete wall. Because of the wobbly action of the water due to wind, these concrete walls collapsed, and you started having water coming into the areas. They tried to use cement bags and sandbags to block them, but they were not very successful. They even tried interlocking steel piles or sheets, and that also they tried during that time, but the breaks were so, the water was so much that they could not, and then the water started getting into cities. These are some pictures. And then there was this big indoor stadium that was damaged. The dome was damaged and the water was everywhere. So if you see here, this will give you the idea what is the problem with this particular city. So this is your Mississippi River, and this is Lake Pontchartrain, and this is your city here. So you can see that the city is at lower than the highest level of Mississippi River. So that means anytime there's a heavy rain here, this will be flooded. We cannot drain the water. So there are so many pumps in the city which pump the water from the roads, and then they put it back into the Mississippi River. That's what they do. So unfortunately, during the hurricane, the pumps also failed, and that created a problem. Again, this is the same story. You can see how the city is below the levels of lake and where's the Mississippi River. So it's like a toilet bowl. And these are some pictures. So New Orleans is basically a bathtub. And this is the actual flooding of a big major city with tremendous amount of water. And the flooding heights reached very high values in the city, into the houses and so on. And not because of hurricane dumping a lot of rain, it's because the lake levees failed because of the wind associated with the cyclone. And the Lake Pontchartrain and nearby areas have a lot of wetlands, and they cleared the wetlands. They could have helped us to protect the city from the floods. So the New Orleans has levees because these levees were protecting the city from Mississippi River. But the problem is that they were not designed for, a category 3. Even though they were designed for category 3, over the age, they have lost their strength. And there was a lot of money that should be spent on strengthening the levees, but the money was diverted to Iraq war and war on terror at that time. And then only 20% of the funds were provided. So hurricane was also a rainfall event. It dumped 18 inches of rain. So 18 times 25.4 millimeters. That's more than, I think, 500 millimeters of rain in one day. And that created a tremendous amount of problems also for the city because they need to take that water, put it back into Mississippi River. And 3 levee breaches were there, and some parts were flooded with 20 feet of water. So you can see that. And this is the classification system we call Anderson Level 2 classification of land use. And you can see that lots of forested areas and then wetlands are there, which was really to protect people from the floods. And you can see a more number of wetlands and the city as well as the Mississippi River. The blue meandering stream or river is the Mississippi River. So wetlands were previously used for good, valuable flood protection, but over the time we lost a lot of wetlands, and these are the percentage of wetlands which are lost. And that is really a bothersome issue because they are really helpful in protecting the floods. And also Mississippi River over the periodically, over the years it got flooded because it's one of the largest rivers. So, and a lot of silt was deposited, and that replenished the wetlands. And then there were lots of plants growing on, and the wetlands were very good. But then when they increased the levee size, these nutrients were not able to go this side, and of course they started sinking. The plants died on this side, on both sides. So, and then silt was not deposited on the sideways, but it is deposited in the channel, that losing the river, what you call storage. So there was pre-disaster plan, and people knew that hurricane was coming. We had a good one, but then there was a mandatory evacuation. But the problem was it was not communicated to the people early on. They thought it will not create problems, and then there was no way to take out people who are disadvantaged, who are economically poor. They need public transportation, but they could not do it. And post-disaster plan, after the disaster hit, there was no action plan at all, bottlenecks in communication. There were blames that the governor was blaming FEMA, the mayor of the city was blaming on FEMA, and so on. And the way how the help can be extended, that was also a major problem. And then there was a prediction by a professor in Louisiana State University who indicated that there will be a tremendous loss of life if a hurricane were to hit, and that was hit. And you can see the amount of damage in billions, depending upon different types of distance. So all in all, what happened in this case of this particular disaster is that we had warnings, we had hurricane warnings, we had everything, but then it was a perfect storm. Everything came at the same time, and there are a few things didn't work out. So lots of people lost lives, and the city was flooded for several days. And it was one of the wake-up calls for the emergency management agencies to work on evacuation plans, and also at the same time how to help people who are in situations where they cannot evacuate themselves. And so this one happening in 2006 or five, in a most developed country in the world, this shocked everybody. I mean, this is the wake-up call for them to have some kind of flood warning systems, flood protection systems, protecting the levees, protecting the pumps which will pump the water, and then also rezoning the areas where you cannot have houses built in flood zones and so on. So there are a lot of changes that has happened after this particular storm hit New Orleans. But unfortunately, by the time people have realized that this is not a safe place to live, so it lost a lot of people. A lot of people have left the area, and it also created a lot of economic problems. It's still recovering from this particular loss, and because of the Katrina, there were a couple of universities were closed permanently. So this is also another problem of the climate disaster, or flooding disaster, which caused this issue. So I think I have covered everything what I wanted to cover about the flood warning systems. So if you have any questions or any clarifications, I'll be happy to answer. And then we can discuss any pending issues for this course which we have left, or if you have any additional questions for me, I'll be happy to answer based on the entire 1 week's worth of material we have learned. There's a lot of material to digest, but at the same time, you have any questions you can ask me at this point of time. Yes, for a higher lead time, the forecast error will also become a little bit larger, and it also becomes uncertain. That is always for any model, for that matter. But if there is a higher lead time, and if you have like an operational ensemble simple forecasting systems, then you have a good idea about the probability of your dangerous situation or flood. Then probably you can still take some preventative measures, help people, and so on. But in general, yes, the larger the lead time, because of the way we are talking about the nature, it's difficult to provide accurate forecasts. So therefore, we have to always rely, whenever we are talking about warnings, we have to rely on a reasonable forecast, and also look into triggers which help us to define the warning message within a reasonable time. And then, of course, the last one is the thresholds. If we can establish reasonable thresholds and then have some automated measuring systems, And for example, in Texas, some time back I was telling you, the downtown of Houston always gets flooded whenever there is a tropical storm. So what they do is they have these automated sensors in different parts of the city, which register the rain. And then when they see this amount of rain, they will start triggering the alerts. They don't have to wait for any other what you call hydrologic simulation model, even though they do it in the background, but they don't have to wait because they can use the rainfall triggers to do that. Any other questions? No? So, Sir Yadav, I cannot hear you. I don't know if you're talking.
Yeah.
Maybe you're on mute.
Yeah.
Okay.
No. I'm on another system. I have kept two systems together. So in case anything happens, I can switch over from one to another. Sir, what I was asking was sometimes the problem is with the DEM vertical accuracy, because we use DEM for flood modeling and various resolution DEMs are available. But when someone asks that what is the vertical accuracy of the DEM, that comes in terms of meters, while our indentation depth is in terms of centimeters. So how to address this?
Yeah, I mean, if you are trying to address your flood levels in centimeters, whereas your accuracy is in meters, then there's definitely a mismatch between those two. I think the DEM accuracy is definitely a problem, not only in India and also many parts of the country, in US also. We are struggling with the DEM accuracy because we are slowly now moving towards LiDAR so that we can have more detailed, more accurate digital elevation measurements. Now, what US has done is taken up the priority areas where there is a general high risk of flooding. They went ahead and started resampling the topography they are using LiDAR so that they can improve the DEM accuracy. So that is one thing they have done. Now, the other thing is that even if the DEM accuracy is, it will affect your results. I'm not saying it is going to affect your inundation extent, it's going to affect the depth of water. But I think in case of flood warnings and flood estimation, my feeling is that we don't need to get accurate numbers. As long as we can provide a sense of what might be the possible exceedance value for peak discharge, and then what is the possible extent of flooding. If we can provide those two from our models, maybe we could have done a reasonable service to the people, provided the accuracy of the data. We cannot suddenly improve the DEM data. That is what my feeling is. Yeah.
One more thing, sir, that can we say like that the indentation depth which we have modeled using the various approaches and the actual depth of water at that place. So can we try to convince or try to answer like this, that the depth which was observed at this particular location is the same as the depth which we have modeled? Will that help to up to some extent convince that the vertical accuracy of the DME doesn't affect the inundation depth?
Well, the vertical accuracy of DEM will always affect the inundation depth at locations where you want to validate your model. It is going to affect that. But as long as you are within a range of the actual value, which is you're trying to achieve, for example, at a location of a bridge, you want to estimate the depth of water. If you are able to get within a small range of, then your model is doing a very good job. There are studies where they have done validation of models even without any data at all. So, I mean, looking at the historical data only. For example, there are studies in Europe where they try to predict the past, reconstruction of the past floods. So they took the previous landscape, land use maps around, let's say, 1920s. And if there was a big flood in that area, they were able to reconstruct to a certain accuracy. I'm not saying that it will be a perfect match or good correlation, but at least within that range, if we can come, then we have done a reasonable job considering the issues we have with the data. So there is a question. Well,
yeah.
Sorry, you want to read the question, or you have another question?
No, sir. Please read.
Yeah. So whether there are any experiences of flood forecast failing, how it was communicated to the people. So there are always forecasts which might fail, but usually what happens is that the warnings are based on not just the hydrological simulation models. The warnings are also based on ground conditions, the trigger levels, the thresholds, the local domain expertise, and all those things. So in that case, even if your forecasting model underpredicts the flood, but your triggers can put that factor of safety. Your triggers or thresholds can put factor of safety. So in that case, you can be more prepared even though your flood forecast will fail. For example, the precipitation forecast which we get on TV every day. I mean, our forecasts are reasonably good. They will tell you how much amount of rain you might get tomorrow, and then what are the areas which will experience rain, what are the areas which will experience flash flood. So if you err on the caution, your projection models can be wrong, but you can still help the people in terms of trying to see how you can protect the infrastructure. You can help them to make guided decisions whether they want to move away or they want to stay back at home. They don't want to drive in a flash flood conditions and so on. So that's why the cone of uncertainty matters, which I showed you for cyclones. For us, the hurricanes, we keep on watching that cone of uncertainty when there is a projection of hurricanes is going on. For example, if I show you NHC, that's National Hurricane Center, we go there, and if you click on that, right now you will see that, I mean, this is more detailed, of course. Let's see if I can. Tropical cyclone activity not expected during the next 48 hours. So this also helps us. And this, of course, we are monitoring right now. And it is going away. So if you are not in this cone of uncertainty, then you can be pretty much confident, because this cone of uncertainty is already a big uncertainty based on multiple model ensembles. So it's like not one model. This is like 10 or 15 models they are simulating to find out the direction of the hurricane. So if you are here, you are reasonably safe. But if you are here, you need to be very careful in how you make your decisions, whether you want to evacuate, whether you want to stay there, whether you want to do something for your protection of your property and so on. That is important. So I think forecasts will always fail. There is no guarantee that forecasts will be perfect. Forecasts will fail. And then the only way is to make sure that we have other additional informations to make that judgment call in terms of warning. And the agencies in United States will not take any chance, because we are, we get different lawsuits from different people, from individual citizens can sue the government, individual groups can sue the government, the counties can sue the government, any type of entity can sue the government for billions of dollars. So therefore, when they are warning you, when they are telling you there is a problem, when they are telling you they are already including a factor of safety, considering that they may be completely wrong in their forecasts. So many a times, every year we prepare for hurricanes and they say it is coming your way. So we prepare, we fill up our cars with the gas tank, I mean petrol or whatever you want to call, and then we wait. Sometimes it comes close, sometimes it goes away. So, but it's very difficult. It's very difficult. So somebody's saying the Annamaya project on Cheriyar River has turned out to be a sorrow of many a village. And so I don't know about the project, but maybe you can tell what is the advantage of this particular project. I'm not sure what did the project involve. This is from question from Raju, I think, or at least a comment. Example, he's saying. Okay. Oh, the irrigation related project. Okay. Yeah. Yeah, I think, it can be a number of things. Let me answer the question of Ayushi. Ensemble forecasts are used in United States. Yes, because the river forecast centers will provide ensembles of forecasts. That means they run for different initial conditions, and they get this band of uncertainty. They can also provide the probabilities, and that will be used for forecast warnings and forecast watches and advisories and warnings. Yes, we are one of the countries, as you have seen in the presentation. We can check this one here when I showed you the website address of ensemble the forecasting centers. We are effectively using one of the centers. We are using the ESP, or streamflow forecasting, or ensemble streamflow forecasting. You can see here also in this one. But if you see here, United States will be there all the time. So we are using, and then you see E is there, that is ensemble. So we are using them, and then and that generally gives us the probability to establish what is going on. Okay, so there are multiple questions. You're not able to see the screen, unfortunately. Oh, maybe I stopped saving the screen. But anyway, in the PowerPoint presentation, you will see that that there are links to those websites which will have the national forecast centers. And you can just type regional RFCs, regional forecasting centers, and you can see that. Few areas of research for young researchers. That's a very broad question, but I think the problem, what you are trying to deal in India, is that data scarcity. That is the main problem. I mean, you have brilliant ideas. The problem is that you don't have data to validate something which you have thought about it, which you have tried to do research on it. So I think that is the main problem for all the water resources and environmental resources research in India, because we have so less data that is available. So my recommendation is, first, don't go into the research areas where you see that your end game is dependent on data, or at least requirement for a strong data structure. So that is one thing. Second thing is, most of the tremendous good quality research which is coming out from India is mostly statistical hydrology. That's because they are very comfortable with statistical hydrology, because the data is available. Long-term data is available, short-term data is available. At some locations, they can come up with some methods and so on. But for students who are involved in hydrological modeling, the hardcore distributed simulated modeling, and so on, simulation modeling, they have this problem of lack of data. For example, we have seen yesterday the issues with Mount Abu, where the students have to struggle, go to village and try to find out water levels from the people, and then try to validate your models. So I would recommend two things. When you start your research, look for immediately the condition that you have data. If you don't have data, don't try to go in that direction, because every research study, the strength of research study depends on how you can demonstrate your approach with a reasonable quality of data. If you don't have that data, then you have a problem. So please don't go into that. The other thing is that whatever you do, whatever type of research you do, try to see that if you can make some minor contribution in the methodology, right? Methodology, when I say methodology, it's not just purely the fundamental changes in the approach or whatever. You may be combining different tools, but the way you combine different tools, the way you bring in concepts from sister disciplines and put it in your area, like for example, AHP is introduced into a ranking of your flood risk zones or flood risk areas or impact areas. So in that case, what you're trying to do is you have a methodology. Now you are trying to improve the methodology by taking some technique which is available in other areas. So the case study data is important, the topic is important, and that minor contribution which you can make to methodology is very critical. That is very important if you are doing PhD, even if you're doing masters. Think for that. How can I take my methodology and add a little bit of tiny contribution to that? That is what is important. Okay, I hope I answered your question, right? Ayushi? Yeah, so Maruf Sheikh wants to seek an opportunity. Yes, please send me your CV. Usually the postdoc decisions are made 1 or 2 years in advance because we have to make sure that we have enough budget or money for postdocs. So postdocs typically we pay around approximately $50,000 US per year. That is a typical range of postdocs. So we cannot suddenly generate that kind of money. So we have to look for projects and we have to wait for the money to come in and we need to plan. So keep in touch. And if I'm not able to provide you a postdoc, I will be happy to forward your resume to other colleagues and the different contacts I have within the United States and outside. So it's a good idea to go to a different place and get a different type of perspective on education or research. That is a very good idea to get out and try different things. So this is good. So please try that for postdoc. Any other questions for me?
Hello, sir.
Welcome, Dr. P.L. Patel, sir.
Yeah, Professor Patel is here.
Professor Patel is here. Sir, in nutshell, how the forecasting system, flood forecasting system of India can be improved? What are the immediate steps, Dr. Ramesh?
Yeah.
What are the immediate steps which we need as per your observations?
So, very good evening, Professor Miss.
Good evening, sir. Good evening.
Good evening.
Good evening, Professor Patel.
It's nice to see you at least on this, through video. So great, for conducting this GAN program for our this institute and participants, of course.
Thank you.
Very
Thank
nice.
you.
Very nice. Yeah. Please.
So,
Anupam and Patel, sir, will start shortly valedictory function. We are at the end of the last session.
No problem. No problem. Please.
yeah. So, Professor Yadav has asked me a question. First of all, we need to see the state of the art of forecasting ability within India. That is the first question we have to ask. Where are we right now in terms of forecasting abilities? So availability of models is not a problem. We can get simple data-driven models to trigger-based models or threshold-based models, then lumped models as well as distributed hydrologic models. We have a tremendous amount of model availabilities there, both public domain and private domain, and they are not expensive these days. So model availability is not a problem. The main problem comes is in threefold. One is the availability of the topographic data. Land use is much easier to get. from any satellite data. So one is the topographic data. The second one is the main precipitation data that is very critical, which drives our models. And the third one is the stream flow data. So these three are very critical for the success of any forecasting model or forecasting agency in producing a reasonable forecast to provide watches and warnings. So all the three are very expensive ordeals to get better topographic data, better precipitation data, and of course the stream flows. So what I see in future is that either two things can be improved based on the resources you have. Precipitation data is now can be improved by the radar facilities you are going to install in the next 2-3 years, and they will become operational, and you should be able to get radar data for your calibration of distributed hydrologic models in a better way than relying on point gauges. That's one thing. Stream flow data, that is very critical. So the existing networks have to be improved and they made reliable, and telemetric gauges have to be there so that you can take the stage levels and use rating curves to estimate the discharge quickly. Topographic data requires investment. So that might be a project related investment where you are looking for a project. So for example, most of the time in the United States, we may not have the real good quality topographic data. So what we do is we write a proposal to the government or state government or federal government saying that we need to do flood studies for this one, and we need to get more finer resolution data sets. So we get that money and we invest on LiDAR data, hire a private agency to map the area so that we can get the better topographic data. So I think the precipitation data, stream flow data can be improved with a reasonable amount of money, but topographic data will require a tremendous amount of investment to improve the flood forecasting capabilities. Now, the second one is that as we keep going to improve flood forecasting capabilities in India, you can see yesterday's talk also from DHI. The main issue he was saying was, we have all the sophisticated models. We have the models which can assimilate data from different sources. We have everything, but the data itself is the problem. So we have expertise, we have models, we have everything, but we don't have the data. So what DHI is doing is, in a very clever way, trying to assimilate data from different sources and trying to populate their models by a reasonable amount of data from different places. But if we cannot improve the forecasting abilities, at least we can improve the forecast warning abilities. So that means if we can install very carefully within a region, for example, in Gujarat or some other place, high flood prone regions, you can always install some primary gauges which might serve as triggers or threshold measurement compulsory gauges. That means, for example, if you install a couple of gauges in Mount Abu, make it reasonably telemetric. That means it's sending the data to you to an office. Then you have really a better warning system than what you have right now. So rainfall triggers is one of the most used method in many of the developing countries. All they need is one rainfall trigger or threshold to actually calculate the things. So somebody saying IIT Madras is supervisory consultant for the real time, okay, for Chennai Basin. Was tested last year and it will be launched this year. So that's the good news. So basically, as I said, there are capacity building exercises where we have to improve. For example, the Chennai radar, I don't know if it is functional or not. If it is functional, that will be very useful for an urban runoff modeling exercise for Chennai. And so similarly, there are 10 other radars that are being planned in future. So I think, I think I saw the news recently that it is having problems, and Delhi also had some problems. I don't know whether it is repaired or not. So again, if you have these kind of sources of input, we are looking at a better warning systems. At least forecast systems are the next stage where we have to aim for, and then in that process we need a lot of investment, unfortunately. And trust me, even fully developed countries do not have a good topographic data, including US. We are, if you see 10 years, they have improved a lot. They have invested a tremendous amount of money in this thing. The second thing is, there are satellites now which can evaluate the stage of this data, that is water data. They can give you the water levels with some accuracy. I'm not saying it is a lot of accuracy. So that means our dependence on stream flow gauges can also be reduced a little bit. That can be done. And then the private agency partnerships. So for example, the city of Surat or some other city which experiences reasonable floods every year, the private entity inside the city can invest on some kind of rain gauges or stream flow gauges upstream of their city to probably provide some kind of mechanisms for warning purposes. So this is what I feel. I think we have everything in place, but the data is the Achilles heel, the main problem with the data. That is what is the main issue. The developed countries can develop operational forecasting systems. They can do better forecasts because they are data rich. They have so many sensors. They have so many gauges available everywhere. The density is much higher. So that's the advantage.
Sir?
Yeah.
Yes, sir. Actually, sir, I'm working in that supervisory consultant, sir, for real-time flood forecasting for Chennai. So in the last monsoon, we were able to. So the project is mainly done by CCON. So CCON is doing the project. The IIT Madras is acting as a supervisory consultant. They are using the mic suite of software for the integration. So this time we were able to, with the help of rainfall forecast from ECMWF, we were able to get the, we are able to give forecasts. So when compared to 2015, where the discharge was totally at the last moment, year prior release was done to the Chambrambakam reservoir. So we were able to achieve up to the hydrologic model forecast, sir. So as I learned from this course, they are planning to install the RT- system in the coming monsoon. So I think from this course I learned that soil moisture is an important trigger. So
yeah.
we have to work
soil,
on that.
I have seen multiple reports, and I have served as a reviewer for the forensic reviewer. After the flood has happened, they will invite experts to find out what is the problem. And we have seen that the soil moisture in different upstream basins or headwaters or anywhere for that matter, soil moisture is extremely critical for floods, and especially for those slow-moving hurricanes or slow-moving cyclones, because they slowly increase the soil moisture, and by the time they come to the area where they are going to dump a tremendous amount of rainfall, by the time it's too late for us to even do anything, because we think that a small amount of rain is coming. So rainfall is one trigger, but the pre-existing soil moisture or antecedent precipitation conditions are very important, and we have seen in study after study. So therefore, soil moisture is one of the, what you call, a boundary condition or a perturbing condition in all ensemble stream flow prediction models.
Yes, sir. So that is one thing which we have to work on. The other thing is we are able to achieve the inflow forecast to the reservoir, sir. But when it comes to the downstream, when it comes to the flooding in the urban areas, we were not able to achieve it because of the stormwater drain. We were not able to capture the model better, the stormwater drain, because of choked stormwater drains. That is one problem.
That's the problem.
And the other point is we don't have like high resolution DEM, as you have pointed out also, sir, for doing. So those are the challenges which are remaining, but we were able to get a good feel of the forecast into the reservoir, sir.
Yeah, I mean, yeah, that is, as you said, no citizen is expecting us to produce perfect forecasts. No citizen is expecting us to match the values, what will happen in future. All they are looking for is a threshold or a probabilistic forecast saying that your area will be flooded. This is the problem, and you need to take care of that. So I think you are doing great as we are approaching that very high resolution data sets, and you are using them to predict in real time. So I think that's a wonderful. The storm drainage network, we also have the similar problem. We most of the time people use the SWIM model to model the urban areas with stormwater infrastructure. Trust me, even stormwater modeling is, especially in urban areas, is still difficult because there is there are points where we don't know where the water is coming from and where the water is going from. So it is, again, that's a major problem even in US and other areas also. But as we say in bacterial forecasting or fecal coliform forecasting, nobody can forecast exactly the number of fecal coliform. As long as we are within the range, we are good. So we can say, we can give advisories, don't go and swim in this river or stream because the fecal coliform is very high. So now that high, that's enough. That's the range is good.
Yes, sir. This time we are we are planning to do with the ensemble also, sir. Last time we gave only deterministic forecast.
Yeah,
so,
I think that's
so this time
that is perfect. Yeah, please go ahead and capture the ensembles and then provide the probabilistic values for possible flooding. That
Yes,
would be more beneficial for everybody, right?
Yes.
Yeah.
Sir, regarding the DEM, Survey of India is flying the drone, sir. Since Chennai is the coastal city and is highly sensitive, so Survey of India themselves are flying the drone, and they are supposed to give us the 30 centimeter DEM, sir.
Wow, that is very good. Yeah. So, I mean, this is an ongoing effort in every part of the world. They are improving
Yes,
the DEM, and that is one thing. Improving the DEM, improving the precipitation estimation, and improving the soil moisture estimation, and improving the stream flow estimation. So these are all 4 areas they are focusing. Some of them they are getting help from radar. Some of them they are getting help from the satellite information. Now they can read the soil moisture directly from satellites. There are a couple of satellites which can actually provide soil moisture. So they are also doing that.
So thank you very much, sir, for the last lecture. And I think we have interacted more than 40 minutes after the lecture is over. So this is the best part of the best part of this course, that we were having good interaction throughout the course, and after each and every presentations. So I hope that all the participants were benefited by it. At least myself, I have added a lot of knowledge with respect to the subject, and got clarity for so many things which I was already knowing. And probably this may be the feeling of all the participants also. So I conclude this session here, and without delay, we start our valedictory function. I welcome Dr. Naveen Kapoor, MD, UP Project Corporation Private Limited. I welcome Anjali Khambate ma'am, retired professor, Civil Engineering Department. I welcome Deputy Director PL Patel, who has joined this valedictory function. I welcome Dr. GJ Joshi, Head of the Department, and I welcome Dr. Praful Timbadia, who is the sectional head of the Civil Engineering Department, Water Resources section. I request Rashmi to proceed with the valedictory function.
Thank you, sir. Good evening, everyone. Respected dignitaries, Deputy Director, SVNIT Surat, Guest of Honor, Dr. Anjali Khambate, Chief Guest, Dr. Naveen Kapoor, HOD, Department of Civil Engineering, SVNIT Surat, foreign expert, professors, and all the participants. I, Rashmi Yadav, research scholar, SVNIT Surat, welcome you all to the valedictory function of one-week Gyan course on spatial analysis for water resources, modeling and management. As we are short of time, I would like to call Dr. S.M. Yadav, professor and coordinator of the Gyan course, to address the participants. Dr. Yadav.
Respected Dr. P.L. Patel, Deputy Director of this institute, Dr. G.J. Joshi, Head of the Department, Chief Guest of the function, Dr. Naveen Kapoor, Managing Director, UP Project Corporation Limited, Dr. Anjali Khambate, Retired Professor, Civil Engineering Department, SVNIT Surat, Dr. Praful Timbadia, Sectional Head, Water Resources Engineering Section, SVNIT Surat, all the participants and invited guests. It gives me immense pleasure to welcome all of you at this valedictory function. As participants are aware that how the sessions have already arranged and how the deliberations are done and the way in which they benefited, probably they know the best. However, for our guest, just I wanted to give a brief of what we have done during these last 5 days. Sir, it all started with 13/6/2022, wherein we have 2 lectures by Dr. Ramesh Teegavarapu, our foreign expert, explaining spatial hydrology analysis of hydroclimatic data and spatial analysis and data-driven approaches for flood prediction. That was followed by Dr. Rajiv Mati, who explained application of COPLA in hydrologic analysis. The second day was followed again by all 3 lectures by our foreign expert, Dr. Ramesh Teegavarapu. And you will not believe, sir, that in none of the lectures, the participants have moved away from the screen. All the lectures throughout the day, it started at 3:30 p.m. and ended at 8:30 p.m. Probably the second day we become late also. It ended at 9 p.m. and that too, I have to interrupt Dr. Ramesh that, sir, it's a 9 o'clock in India and some of the girl students have to report the hostel within the time limit. So on the second day, spatial and statistical analysis of floods, hydrologic design under changing climate, and spatial and statistical analysis were discussed, giving the real-time examples explaining how these analyses be useful to solve real field problems. The third day, SK Jain, Head and Nodal Officer, National Hydrology Project, give an excellent lecture on the Himalayan region, hydrology of Himalayan region, at the same time explaining the Indian hydrology scenario, and the participants were shocked to see that the National Hydrology Project in real time, so many projects, what number of softwares they have completed. And it is really an inspiration for young researchers that the way in which the National Hydrology Project carried out the work in the same manner, the participants may inspire to carry out the work. It was followed again by the Dr. Ramesh lecture on climate change and variability influence on hydroclimatic extremes. On the same day, I have explained spatial modeling of flood risk, giving a live case study of Girna Basin, how the spatial modeling has been applied to Girna River Basin, and what are the outcomes of this spatial analysis. On the fourth day, hydrologic simulation model in virtual reality application for floods, wherein Dr. Ramesh have explained that the newly joined graduate students, those who have not seen the flood, what is the flood, how the flood moves, what are the flood depth, how the inundation takes place in the city, that he has tried to show using the virtual reality applications. This particular lecture was followed by panel discussion, and I am very happy to inform that more than 15 experts all over the country joined for this panel discussion, wherein Dr. Ramesh has already given 7 points that how we can look at the status of hydrology in our country. And these 7 experts, including Chief Engineer of Minister Jal Shakti, Dr. R.N. Shankua, Dr. S.K. Jain, Anil Lohane, the chairman retired now, Mr. M.B. Joshi, and other professors participated in this panel discussion, and it was really a fruitful discussion which resulted into giving clear idea about what is the Indian scenario, what is the impact of climate change on Indian hydrology, Indian flood projects, and how we can able to, or how the improvements can be brought into it. In the last session of 4th day, Manish Kumar from DHI, he discussed the real-time flood forecasting system, a case study of India. And he explained how the DHI tried to manage or uses the flood forecasting system for the river basin which we have developed. On the last day, today, Dr. Ramesh has given 2 lectures. One was on ensemble stream flow forecasting, which is a need of the developing countries are practicing this since last 25 years. And in India, we have recently started, maybe 4 or 5 years back, that ensemble forecasting by IITM Pune. That was followed by, again, Dr. Ramesh's lecture on flood warning systems. Part of the discussion, probably those who have joined, they have already listened that how we can bring into improvement, specifically in case of India, in early warning system. And the outcome of entire Gyan course of 5 days is that we need to develop some system, not only for India, but for world, that we can predict the flood or heavy precipitation at least 10 days in advance, so that we can able to take measures to safeguard our structure, to safeguard or to issue early warning system, and prevent loss of life and damages. Lastly, the hands-on session on flood hazard assessment that has been taken by me, wherein participants have themselves tried to identify flood hazard watersheds for the data which was given. So this was all throughout the 5 days. Almost all the session started in time and ended in time. Probably that is the best thing of this particular course, wherein neither the foreign experts, though the timings of the course in India as well as that of USA are different, but that has not affected at all, and all the sessions conducted on time. Thank you very much.
Thank you so much, sir, for the insightful words and brief overview of the course. Now, I would like to invite my fellow scholar, Urvashi Malani, to give a brief introduction of the Foreign Faculty of Gyan course. Urvashi.
Very good evening, one and all. Myself, Urvashi Malani. Dr. Ramesh Teegavarapu, he's a professor, a Fulbright scholar, and graduate program director in the Department of Civil, Environmental, and Geomatics Engineering, and the founder and director of Hydrosystems Research Laboratory at Florida Atlantic University, USA. He has over 25 years of experience in hydro-environmental systems, modeling, and management. He has served as his main research interests include climate change and variability, hydroclimatic extremes, water and environmental system modeling and management, special hydrology, and hydrometeorology. He is an author, co-editor, and sole editor of several books on these topics, along with several book chapters and over 160 peer-reviewed conference and journal publications. He has received several university-level, national, and international honors and awards for his research activities. He serves on several international tasks and technical committees from multiple professional organizations related to water resource management, considering climate change and adaptations. And now I would like to invite Dr. T to share his experience with us during these 5 days of online Gyan course. Over to you, sir.
Sir, your mic is muted.
So, first of all, I'd like to thank Urvasi for that introduction, and also Professor Yadav for initiating this course. We've been trying for the last 2 years to get this course, and then COVID came in. And then we worked very hard to get the organization of the contents of the course, and successfully getting the support from the Government of India and IITG, where Gyan is there, Kharagpur. So my impression is from this course, I really enjoyed understanding the Indian context with the number of experts who talked about the problems, including Professor Yadav presented multiple topics related to flood forecasting, flood impact measurement, and so on. So this is a wonderful platform where I could understand the problems facing in India, and at the same time share my experiences, what I have done and what I have learned from US and other countries about forecasting of floods and handling floods, and then spatial extremes, and all of the topics which are highly relevant. We also brought in the industry experts. We brought in the panel discussion where we have all the experts contributing to this particular course. More than all these things, the students, the participants have really shown a strong interest. I was really surprised, because usually online courses, where people just log in and then they fade off, they don't ask any questions at all. But there were questions after questions, and there were exciting questions, interesting questions, difficult questions sometimes to answer. And then also we spent a long time, even after after our session is over, we were talking about these questions. And I think it's the combined knowledge we together has generated. This will be an extremely useful exercise for me, also for you, I'm sure. And then at the same time, I learned a lot of modeling issues in the context of Indian regions, different regions. And then I'm really appreciative of Gyan as well as SVNIT for taking this lead and having this course. I really miss coming to SVNIT because of some bad planning I did. So hopefully in the near future, I will come to SVNIT and then meet with all you guys, and then talk about different things. But you're always welcome to approach me by email if you need any sort of help with your research and anything. Whatever I can do, I'll be happy to help you. And I also want to thank the department head, Deputy Director Dr. Patel. We have a long association, and all the PhD students, researchers, and all the Indian experts who have participated in this one. This has been a wonderful experience. I thought, online courses are a little bit difficult because you lack that personal interaction, but this was very good because every student has really communicated, asked questions, and their interaction and participation made this course very very exciting, I would say, because nothing excites a professor by having very excited audience. If you don't have excited audience, we don't want to teach. But this was an opposite case, and I really enjoyed every single part of it, and I look forward to more interaction with SVNIT. Thank you so much.
Thank you so much, sir, for the humble words. Sir, we have enjoyed every lectures and every suggestions by you. Indeed, it was a joyful learning experience, sir. Now, I would like to invite Dr. G.J. Joshi, Head of the Department of Civil Engineering, SVNIT Surat, to address the audience. Dr. Joshi, sir. I think he is not present right now. So I would like to invite Deputy Director, Dr. P.L. Patel, SVNIT Surat, to address the audience. Dr. Patel.
And very good evening, you all. Particularly our course expert, Gyan course expert, Professor Ramesh from Florida Atlantic University, USA. Course coordinator, Professor S.M. Yadav, course, our head of the department, Professor GGOC, sectional head, Dr. Timbadia, and other dignitary present over here. Of course, I think Dr. Naveen, support from UP Project Corporation Limited, and our here participants, what around 50 participants are there. So very good evening, you all, and very nice to meet you again in this your valedictory session. We had last met in inaugural session. So I think the kind of feedback we have, I was hoping that, and actually it happened, that Professor Ramesh, who has given this kind of course, I'm sure that 100% strength was supposed to be there, and that is reflected from the feedback from these experts and Professor Yadav. So I hope this course will be very, very useful. I am sure that this kind of expertise in the area of hydraulics and hydraulic engineering you won't find very rarely, I can say. So I hope the kind of knowledge imparted by Professor Ramesh and other experts who are there from India, I think will be very, very useful to you. Please carry it with you, and my one suggestion would be there that there are a lot of notes and everything, but please use after going from here. It is not like that you keep with you and then that's all. So please use that, and I'm sure that it is very, very useful, particularly the recent techniques, which is given by the Professor Ramesh and other experts. Please take it on. And I would like to thank Professor Ramesh particularly, who has given a lot of time for this lecturing to our participants. And sir, surely I think we have the kind of collaboration in future also. So thank you very much. And I am Professor Yadav is concerned for thank you very much for organizing such course, and many, many compliments from our side that you have done great job, and please keep on doing that. And also the thanks to our other experts like Professor S.K. Jain from IIT Roorkee, Professor Maiti from IIT Kharagpur, and some other experts from DHI and Central Water Commission. So I will definitely thank to them also. So with this, I will convey my best wishes to all these participants. And again, I would thank Professor Ramesh to be here for this kind of course and helping to our participants. Thank you very much. So nice. Thank you.
Thank you.
Thank you, sir. Thank you.
Thank you so much, sir, for the wishes. Yes, sir.
Dr. Joshi have joined.
Yes, sir. I would like to invite head of the department, Dr. G.J. Joshi, to address the audience. Dr. Joshi, sir.
Very good evening to all of you. Actually, in my office, the net connectivity was very poor. So I'm now in my car and I am able to connect with this function. But I had opportunity to listen to some of the responses by our foreign faculty, Professor Ramesh, and I was really fascinated by the challenging job he has been doing, and he has sensitized the participants to take up the most difficult task in a present context, to forecast the events of extreme nature in urban areas, because we know now that the weather has become quite unpredictable because of the effects of the climate change. uh, I'm sure what Professor Yadav summarized, it has been a very, very excellent program with contribution of very resourceful, eminent speakers. But the most challenging part, what we consider now, is how to make the forecast very much adaptive and dynamic, because climate pattern changes every year, and every month of any particular season, and therefore that remains quite challenging for the researchers and the professionals working in this area of forecasting of these extreme events of flood, particularly in cities, because the cities form economic backbone of any country. If the economic activities come to standstill, movement of the people becomes difficult, then naturally the economy of the country gets severely affected. But nevertheless, I hope the young researchers might have got lot of motivation and encouragement to take this task further. and they will help countries like India with massive population living in urban areas, more than the population of United States entire country put together, and it's going to be almost point seven seven point five point 7 billion by the mid of the century. So it's a huge challenge for urban planners, transportation researchers, water resources engineers, everyone. So in that context, you have great role to play, and I think this course has enabled you to look forward for your role, very important role for making our cities. I would put it like resilient to the climate impacts, and that would be a great contribution. I also take note of the presence of the chief guest, Sri Naveen Kapoorji, also my former colleague and Professor of Department of Civil Engineering, Dr. Anjali Ben Kambete, and Deputy Director of the Institute, Professor P.L. Patel. And I must speak here that the Water Resources Engineering section is doing wonderful job as a group, as a team, and also under the Center of Excellence for Water Resources and Flood Management. So I thank all the foreign speakers, Indian resource persons, and also I would like to compliment my colleague Professor S.M. Yadav, who has nicely navigated and coordinated this program and made the human service to the young researchers community of the institute and the country in at large. Thank you all and all the very best. Thank you.
Thank you. Thank you.
Thank you so much, sir, for the insightful words. Now, I would like to invite one or two participants to come forward and share their feedback about the course. Yes, Aarti ma'am.
Good evening, everyone. So, Aarti this side. Being a research scholar in the Department of Civil Engineering, SNIT Surat, and working on the extreme rainfall analysis under the changing climate, I thoroughly enjoyed this 5 days course, and especially it was a great opportunity to listen Professor Ramesh, as he has covered the wide aspects of statistics. The insights given by him on the stationary and non-stationary frequency analysis under the changing climate, the issue, challenges, and the management of the extreme events. Moreover, the open panel discussion and the questions raised are really food for thought. And the statistical tool, the highlights on the statistical tools like Copula and AHP given by the other experts. And lastly, the advice given by the Professor Ramesh as at least the delta X addition in the methodology is much more appreciated advice for all the students who have attended and thoroughly enjoyed this particular course. So I would like to thank you, Professor Ramesh, as well as Dr. S.M. Yadav, sir, to give this wonderful opportunity to all of us. Thank you.
Thank you, Aarti, for kind comments.
Thank you.
Thank you, Aarti ma'am. Any other participant want to share the feedback?
Yeah, good evening. Can I speak? I'm Vipin.
Yes, sir.
So I would like to mention three things about the whole course. Firstly, the GAN course. This is my first course I have attended as a GAN course, and I am very happy and very satisfied by this course. Realizing this has created a perfect niche for its own kind among all the training programs available. It has made us attend the course while we are working on other things also, and it has maintained the consistency. It has given us opportunity to interact with the presenter in like a live session. So it is a solution which was just missing in all kind of training programs. So second thing is the foreign expert who has been with us throughout the training has remained present for almost every minute, and he has been very forthcoming. He has explained all kind of things in very simple words, so which has been very helpful to understand even the peculiar things about the hydrological process. And thirdly, I want to give an example how the training has been. It has been like a DNA structure. So the whole thing has revolved around the core subject of hydrology and hydraulics and climate change. And a number of lectures have been handling different points related to that core theme, but they never left the core. So that was the beauty of the whole session and whole training program. So I am very thankful and I congratulate the organizing team, and I am giving humble thanks for including us into this program. Thank you so much.
Thank you. Thank you so much.
Thank you, Vipin sir.
Thank you so much, sir. If any other participant want to share his or her feedback, it is welcome.
Yes, good evening.
Yes, sir.
So, good evening, everyone. Uh, all the sessions are very informative, and all the experts have given the deep inside knowledge. And I am very much glad to be a part of this GAN course as I am attending this first time. And I learned about many things related what is the impact of climate change, then climate change variability, statistical analysis, then flood risk assessment, flood hazard mapping using AHP, flood vulnerability, time series data analysis, flood resilience study along with the flood mapping. And one of the most interesting part of this GAN course is the real case studies and the practical problem, which is discussed in each and every session by all the eminent experts, which gives each and every participants a in-depth information as well as the practical idea, which directly help to the beginners and the young researchers. Dr. T. Ramesh has also discussed many topics which helps the researchers for selecting the research topics, and also sir has given various inputs to the query which is asked by the participants in each and every area of the flood, or you can say the climate change or the climate change variability, flood hazards, partial flooding, everything. Dr. S.M. Yadav, who have given the deep inside information about the flood hazard, flood risk assessment, and AHP. Panel discussion also help in getting the different views from various eminent and the experienced expert from academician, consult industry side. So I would like to thank all the coordinators, Dr. T. Ramesh and Dr. S.M. Yadav, for arranging such a wonderful workshop. And one more thing which I would like to share, and very much glad and happy to share among all the participants, that with this workshop, that is the GAN course, Dr. S.M. Yadav, the coordinator of this workshop, had trained more than 2,500 persons in the area of flood modeling. So once again, I congratulate Dr. S.M. Yadav for arranging such a wonderful training course. Thank you so much.
Thank you. Thank you so much.
Thank you so much, sir. Now I invite Miss Ayushi Panchal to introduce today's guest of honor. Ayushi.
Yes, thank you, Rashmi ma'am. I'm going to introduce Dr. Anjali Khambete. So Dr. Anjali Khambete has completed her BE from SVR CET, SVNIT in 1979 in civil engineering. She has finished her master's in environmental engineering and PhD in wastewater treatment. She has teaching experience of 37 years and published more than 65 papers in peer-reviewed journal. She has presented more than 42 papers in national and international conference held in USA, UK, Australia, Switzerland, Egypt, Greece, and many more countries. She has guided students from PhD, and she has also worked as Dean Planning and Development. She took VRS in 2021 and working as a nominee director at VGEL Papi and SCI Sarigam. She is also a member in audit committee at GPCB. She is actively taking part in problems related to industrial wastewater, air pollution, and solid waste management, TSTF sites, landfill sites, etc. She has published 5 books on wastewater treatment. So now I would like to call guest of honor, Dr. Anjali Khambete. She is retired professor from SVNIT Surat, to address the participant. Anjali ma'am.
Ma'am, unmute your mic.
Good evening to everybody. Thank you, Ayushi, for a brief introduction, and a very enthusiastic course coordinator, Dr. Yadav, for giving me an opportunity to address a very talented and scholar students over here by attending a joint course. The title is also very good. That is a special analysis for water resources modeling and management, where we require a lot of data, and for that Dr. Ramesh must have guided you very nicely while attending this function. I have noticed that Dr. Ramesh and other your experts from different colleges, IITs and ITs, they have given you a a very good knowledge for modeling and water resource management. Uh, you all are very lucky over here. I many times feels that you are very lucky that this online facility has made us very easy to attend such courses. The distance is not a problem. See, from a distance of 12 hours behind than us, Dr. Ramesh is taking lot of interest in graduating or teaching or sharing this valuable knowledge with the students of SVNIT, which is at Surat. So thank you, sir. Being my college, SVNIT, I feel that my students, maybe I may be from environmental sections, but you are dealing with a water and I am dealing with a wastewater. The problem is same. Once the water get discharged, then 80% we further think and make it clean. So modeling is always with us. The data is insufficient. So modeling takes a lot of fuzzy informations and we have to address them in correct way by a fuzzy knowledge. Here I am telling the dais or dignitaries, Dr. P.L. Patel, our HOD G.J. Joshi, and Praful Timbadia. They have also given certain knowledge regarding this. And again, at the last but not least, for giving me an opportunity to address such a talented gathering of a hard-working students by attending such a interesting topic over here. I am expressing my thanks to a course coordinators and the facilities provided by my college over here. Thank you, sir. Thank you very much.
Thank you.
Thank you so much, ma'am.
Rashmi.
Yes, sir. I think chief guest has.
1 minute.
Yes,
Let
yes.
me welcome Dr.
Yes, sir.
Vaidu Patil, Gyan course coordinator at SVNIT. And as Dr. Patil know that since last 2 years we are trying hard to arrange this particular Gyan course. Sir, it will be fine if you can say something about how difficulties we have faced in organizing this online course. Dr. Vaidu Patil.
Thank you very much, sir. Good evening to all of you. Actually, it is a great pleasure to me that this course is being successfully conducted by Professor S.M. Yadav, sir. And since last 2 years, I would like to attention to all the participants that last 2 years, Professor S.M. Yadav is working very hard how to make this program to be successful. Particularly, his wish is that he wants to conduct this program offline, and he wants to invite Professor Ramesh, okay, so that Professor Ramesh will going to come to SVNIT and will going to give a expert lecture. But anyhow, though it is might be conducted offline, but online, there are many participants who have been participated, and they took the advantage of this program. Once again, I congratulate to all the participants. Okay, and I would like to say that Professor Ramesh, it's a I will say that it's a really Professor S.M. Yadav. Okay, the way he was working throughout a whole year, he has done number of emails to me. He has done number of emails to the GAN office that how this program is to be conducted offline, and you are to be get invited in India so that our students and the participants will get benefited from this program. But anyhow, sir, I would like to thank from the bottom of my heart that this program has been conducted, and I will really say that the patience which Professor Yadav, S.M. Yadav has been kept till the last stage, and he made this program to be successful. So once again, I would like to congratulate to all the participants and Professor Yadav. Thank you, sir. Thank you very much.
Thank you, Dr. Patel. It was really a lot of hard work from Professor Yadav. This made this thing possible, and I really appreciate SVNIT and all the coordinators who have worked very hard. And I'm grateful to Gyan for giving me this opportunity to interact with a lot of talented young students, who will come and help the country in the future. Thank you so much.
Yeah. Thank you, sir. Thank you.
Thank
Dr. Yogesh, let me add here.
Yeah.
I was sending mail to you. At the same time, I was repeatedly mailing to Dr. Ramesh also. And he will not ready to believe that it has never happened that he has not responded to my single mail. So that's
Yeah.
even though he keeps so busy, almost for all of my mail, he has
Yeah.
responded immediately. So thank you, sir.
No, sir. We be really grateful to you, sir. We are really grateful to you, sir.
That's right. Thank you, Professor Yadav.
Thank you.
Thank you so much, sir. Now I would like to invite Dr. S.M. Yadav to introduce the chief guest of valedictory function. Dr. Yadav.
The chief guest of today's function is Mr. Naveen Kapoor, Dr. Naveen Kapoor. He graduated from in 1985 BTech SBTI Kanpur, and he joined first Titan Company, and then in 1991 he joined Irrigation Department. His brothers, he has designed barrage and gate designs. He has completely automated them by providing a SCADA system. Recently, he has been pioneer since last 4 to 5 years as a flood mitigation measures. He has adopted dredging of the channels successfully. Apart from that, he has been pioneer to install solar system over state tube wells, and these tube wells need no power and they are working on the solar system. He has developed energy efficient works, so many energy efficient works carried out throughout the Uttar Pradesh. He is presently working as a managing director, Uttar Pradesh Project Corporation Limited, Lucknow. Unfortunately, right now he is talking with Honorable Chief Minister of Uttarakhand. He has received a call when he was attending this meeting, and because of that, he is not present in the meeting. But hopefully that before we disperse, he may join. So thank you.
Thank you.
Thank you so much, sir. Now I would like to call Mr. Mohammad Maruf Sheikh to present the vote of thanks to all the dignitaries. Mr. Maruf.
Thank you, Rashmi. Now I want to thank those who have helped in organizing and successful completion of this course. First of all, I want to say thank today's chief guest, Mr. Naveen Kumar, Managing Director, UP Project Corporation, and guest of honor, Dr. Anjali Khambate, retired professor at SVNIT, for sparing their valuable time with us. I am glad to thank Professor P.L. Patel, a Deputy Director at SVNIT, for their presence at the valedictory function and for encouraging us to undertake such activities. I am also glad to thank Professor G.J. Joshi, Head of Civil Engineering Department, for presence and his support in the conducting this course. I want to express my gratitude to IIT Kharagpur, National Coordinator of GYAN, Professor Adrijit Goswami, IIT Kharagpur, a Group Coordinator of GYAN, and Professor Y.D. Patil, Local Coordinator of GYAN, SVNIT, for providing funds as well as guidance at every stage for conducting this course. I would like to thank Professor S.M. Yadav, a course coordinator of GYAN, for arranging such an esteemed course for us. I am also very much thankful to Professor Ramesh Teegavarapu, Florida Atlantic University, USA, for who have agreed to spare his valuable time and share his knowledge with us. I want to also thank some other experts for delivering such an informative talk, like on the first day, Dr. Rajiv Mehti, Associate Professor, IIT Kharagpur, give us the knowledge on copulae and its application to hydrologic analysis under the climate change. And on third day, Dr. Sanjay Jain, scientist and head, WRS Division, NIT, NIH Roorkee, for the lecture on the modeling and managing water in a future. Fourth day, Manish Kumar from DHI, for showing us a case study on a real-time flood forecasting system. And of course, Professor Yadav for delivering talk on AHP methods on a Middle Tapi Basin, as well as hands-on session on AHP, 1D, 2D hydrodynamic modeling of a Banas River Basin, and hands-on session as well. I want to thank the many experts for the participation in the panel discussion session, like Dr. Jay Kumar, Emerite Professor from NIT Warangal, A.H. Lohani, scientist from NIH Roorkee, Dr. Asawa, Adjunct Professor from SVNIT Surat, Dr. Dhruvesh Patel, Associate Professor from PDPU Gandhinagar, Dr. R.N. Sankhwa, Chief Engineer, Ministry of Jal Shakti, Hyderabad, Dr. M.B. Joshi, Retired Managing Director, Narmada Nigam, Gandhinagar, Dr. Thampi, Professor and Head, NIT Calicut, Professor Aldo, Associate Professor, IIT Bombay. I would like to thank Dr. J.D. Kale, PG in charge, and Dr. P.V. Timbadia, Sectional Head of Water Resource Engineering, for their support. I would also like to thank CCE section, Account section, Estate section, Hostel section, and Guest House in charge for extending all necessary help to conduct this course. I would also like to thank Shri A.J. Solanki, PG in charge of Transportation Engineering, for providing the conference room and the other resources. I am extremely thankful to the student coordinator Rashmi Yadav and other scholar Urvashi Malani, Ayushi Panchal, Bhavin Badgujar, Vipin Tiwari, Shravani Yadav, and Pallavi Patroth for helping in the smooth management of this course. I would also like to thank Rashmi Yadav again for anchoring entire course, and Vipin Kumar Yadav for handling panel discussion sessions short nicely. We are thankful to Sajan Patel, lab assistant, entire office staff, all peon of civil engineering department for helping at every stage. And last but not least, thank you very much to all the participants of this Gyan course for registering an active participation in this course. Lastly, we take this opportunity to thank everyone who helped directly or indirectly in the successful completion of this course.
Thank you so much, sir. Now, towards the end, sir, shall we?
Yes.
Shall we? Okay. So, towards the end, I request everyone to rise for Rashtragan. I invite research scholar Ayushi to recite.
Okay.
Thank you, Rashmi. जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तव शुभ नामे जागे तब शुभ आशीष मांगे गाहे तब जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे थैंक यू
So, thank you, Professor Ramesh. Great. So nice.
Thank you so much. Nice to see you again.
Nice to see you.
Hopefully, we'll meet in Surat soon.
Yes, sure. Why not? Definitely, when you come next time in India, please let us know.
Yeah, I'm planning to come in December sometime, so I will come to Surat.
Surely, surely. Most welcome. Thank you very much.
Thank you.
So nice. Thank you. Bye.
Thank you so
I
much.
request
Thank you
everyone
all.
to switch on their cameras once so we can take one valedictory picture.
Dr. Patel, please stay. We want to take one photograph. Dr. P.L. Patel, sir.
Yeah, he's available.
It's taken, sir. Thank you. Thank you, everyone.
Thank you. You are muted, Professor Yadav.
Thank you, everyone, once again. And
Thank you so much.
We'll meet soon, sometime in such course again. Thank you.
Thank you so much for all your help and all the participants and all the experts, and millions of thanks to Yadav to make it, Professor Yadav, to make this course happen. You know, this is a dream come true for a long time. So
Yes,
thank
sir.
you so
Yes,
much
sir.
again.
Yes, sir.
Thank you.
Thank you.
Thank you. We'll be in touch. Thank you.
Thank you, sir.
Bye-bye.